G'day and welcome to part 3 of our video training series on Stramit EX-facta purlin design software. In this video I'll show you how to use the software and explain each of the screens inside the software. I'll also demonstrate how engineers can use the EX-facta software to optimize your purlin design with a real life example. So let's jump in and fire up EX-facta. Okay, so let's start up the EX-facta software, and you'll first see the disclaimer each time you start the software, and as long as you agree with the terms in the disclaimer you can click on accept to continue. And this is our launching page. So on here we have the enter projects button. This will take you into the Stramit EX-facta software, but we also have other little snippets of info here. For example, Exacta info gives you a brief description of the Stramit Exacta product. If you're an architect or a specifier, you can find a sample specification here that you can copy and paste. Some information about the materials that Exacta purlins and bridging are available in. About us will give you some information about Stramit building products and the Fletcher building group. Stramit info gives a little bit of a history of Stramit as well as the position for Stramit today, and some photographs. So if you want to see some sample photographs of some Stramit purlins and bridging in some commercial projects, you can find them here in this photographs directory. So I can just close that, and I will now go into the software by clicking on the enter projects button. Now each time we start up our projects we'll have a notice here asking us if we want to turn on the help tips. This is a very useful tool for beginners, so we'll select yes. So now if I put my mouse over any of the buttons or features in the software, it gives me a little bubble that explains the feature or what the software is expecting. To turn that off, I can just click on help and go bubble help tooltips turn on or off. So that's now disabled. The next thing is that up here you'll note that it says this software, Stramit EX-facta, is only applicable to Stramit Exacta purlins and Stramit bridging. It can't be used with any other products. The next step I will do is I'll give our project a name. So I'll call it purlin demo, and I can put in a description so that I can understand what it is at a later date. So I'll call this sample roof design. Now for my demonstration here I'm going to use Stramit Exacta Z purlins, so it's already enabled, and I'm going to click on the simple span type option here, the first one at the top of the list, and I will put in 6 spans. So once I enter a number here it will fill in some tables. So the next thing, moving through the boxes, I can either check the purlin size or find the purlin size. Check purlin size is useful if you already have a good idea for what purlin you're going to use and you want to just do a check, but most of the time we'll be using find purlin size. So we'll leave that selected. The next section is restraint from sheeting attached directly to purlin. Now if it's a screw through roof or a Stramit Speed Deck Ultra concealed fixed roof, you can select yes, but if you're using a concealed fixed decking other than Stramit Speed Deck Ultra, or you're using insulation spaces, then you should select no. So for this example I'm going to click on yes, and next I'm going to put in my span length. So I'm going to put in 7,000 millimeters, and it automatically fills in all the spans so they're equal, and I just want to change one to make it 8 meters. That's span 3. And as soon as I click out of the box you can see that there's a graphical representation above, and this updates after you click out of each box. Now this graphic representation shows where the purlins are supported, the default bridging locations, the span numbers, and the lap. I can zoom in using the zoom plus and zoom minus, or zoom to fit. Next is the laps. Now I'm using Z purlin, so I can have a lap on these purlins, and their default is set to be yes and a 7.5% lap length. If I want to change them I can just go in and change the number, and you can see it'll update the graphic representation above. Now I'm just going to set it back to the default of 7.5%, and move on to bridging. And bridging, it is put in a row of bridging and at the recommended spacings. But again, if I want to change these, I can just select and click on the buttons. So for example, I've put 2 rows of bridging in span 1, and you can see it's updated there, and it uses the recommended default spacings. So for my example, I'm just going to go back to 1 row of bridging. Just click on default bridging there to ensure that all the numbers are at the recommended numbers. And this is now complete, so I can move on to continue to adding load cases. Now, just before I do that, I get a little warning box pop up, and it's telling me that I have an unbraced length in spans 1 and 6 that is greater than recommended. Do you want to continue? Now, this is picked up that I have a distance between a support and a bridging that's greater than the recommended distance, and do I want to change it? You can ignore the warning if you like, or you can change the values, maybe add another row of bridging if you like. For this example, I'm just going to say I just want to continue. Click on yes. So now we're on the load case page, and here we can enter in different types of load cases. We can enter in primary load cases, which are individual loads. And there's a note here that it's recommended that you put in a 0.1 kilopascal dead load to account for metal roofing and purlins, as the software doesn't automatically account for dead weight. And we can also put in combined load cases, and these are linear combinations of the primary load cases. So to start with, I'm going to create a primary load case and click on New PLC. I'm just going to give it a name. I'm going to call it AA, and for this case I want it to be a strength case. And then I click on New Load. Once you click on New Load, you can select whether you want the load to be a uniform distributed load, a point load, a line load. For this example, I'm going to click on UDL, Uniform Distributed Load, and I'm going to then select the load application. So I can either apply the load to part of a span, a single span, multiple spans, all of the spans, or I can also do wind loads. So for this example, I'm going to select multiple spans, and I want my load to be applied on spans 1, 2 and 3, so starting at span 1, ending at span 3, and my load is going to be, as a force, kilonewtons per metre, and that's going to be 3 kilonewtons per metre. Then I'm going to input another load, so click on New Load, and this time around I'm going to put in, again, a UDL, and I'm going to use a wind load. And with wind load, we put the wind load in using elements. So we're already on element number 1, and what we do is we specify the areas where the load is applied. So for the first element, I'm going to start at the left end of the structure at 0, and I'm going to go up to a quarter of the way along the purlin, and I'm going to put in a load of -3 kilonewtons per metre. I'll click on Add Element and add in the second element, and this time it's going to go from 0.25, quarter of the way along, to 0.5, halfway along. This is measured as a fraction of the length from the left end. If I want to, I can also put in an absolute length. And for this element, I'm going to put in -2 kilonewtons per metre. And then one final element is going to be from 0.5 to 1, and it's going to be -1 kilonewton per metre. So that is my first load case called AA. I'm now going to create a second load case, or PLC, and it's going to be called BB. And this time I'm going to use a moving load. Now, moving loads can be useful for looking at a load that's moving on the roof. It's also useful for assessing local pressure areas. So with this moving load, I'm going to say that the load traverses from the left end of the structure to the right end of the structure, and the width of the moving load is 2 meters or 2,000 millimeters. And I'm going to put this in as a pressure rather than as a force. So I'm going to put it in as kilopascals, and this load is going to be -1.33 kilopascals. And when I put in a pressure load, I also need to put in the purlin spacing. So in this case, my purlin spacing is going to be 1,500 millimeters. And finally, I need to specify how many test positions. So this is how many chunks along the beam does it do the calculation for. So I'm going to leave it at the default of 20 and then click on OK. So this shows me my moving load and the range that it moves over. Next, I'm also going to put in an axial load, and this axial load is going to be a compressive load, and I'll select it to be 2 kilonewtons. Click on OK, and then you can see I've got an axial load being applied to the structure of 2 kilonewtons. So that's load case BB. Next I'm going to move on to case CC, and this time around I'm going to put in a point load, and I'm going to put it on span number 1, and it's going to be an absolute length, so let's say 3500 millimeters along span 1, and the load is going to be -2 kilonewtons. Also, this is going to be a serviceability load case, so I'll click on serviceability, and I can specify the deflection limit. In this case I'll leave it as the default span on 150. So that's my 3 load cases now created, and I can click on them to see them on the screen. And so the next thing that I want to do is create a combined load case. So I'll click on combined load cases here, and I need to create a new CLC. So the first thing to do is give it a name, and I'm going to call my first combined load case YY, and then need to select the primary load cases that I wish to put into that combined load case. And for this example I'm going to use load case AA, and I want to factor that by 0.8 or 80%, and I also want to combine that with load case CC multiplied by 100%. So combined load case YY is going to be 80% of AA plus 100% of load case CC. I'm going to create a second combined load case. I'm going to call this one ZZ, and I'll do the same thing. I want load case BB, and I can just enter in 0.8, and I want to add 120% of load case CC. So I can either type the numbers in here in the multiplier, or I can select from the drop-down box. So I've added those 2 load cases in. Again, I can click on them to check the numbers, and this is now complete. The next step is to continue on to our calculation, but before we do that, we can click on Choose Load Cases for Analysis and Design. And this area allows us to select which load cases we wish to analyze. So by default, the software will calculate all of the primary load cases and all of the combined load cases. But if you only want some of the results, you can deselect the loads that you don't want to calculate. So for my example, I'm going to turn off CC and AA, and I just want to look at the results for BB and YYZZ. So click on OK, and next step, click on Calculate. Okay, so now we're on the results page, and the software has calculated the load cases that I selected, so BB, YY and ZZ, and I can just click on the different buttons here to see the results. So the software calculates the bending moment diagrams. I can also, if I wish, look at the shear force diagram as well, and if I want, I can zoom in on the different parts of the design. So zoom back out, turn off the shear force diagram, and we can see some numbers on the screen. So it gives us the maxima and minima of the bending moment diagram. We can also see the percentage of lap, the span dimensions here, and we can see our bridging. Now with some of these load cases where I selected the moving load, you get 2 bending moment diagrams, and this gives you the upper and lower bounds of the bending moment as the moving load moves across the structure. So those are the results, and once we've reviewed that and it all looks okay, we can go to the next step, which is moment capacity design. And what this is doing is it's finding the appropriate purlin size for each of the load cases. And so here we can now see for each of our 3 load cases, it's telling us what purlin size is required for that span. We also have down here a number of other solutions. We have the one solution or single solution, and this is the solution that satisfies all three load cases. And so that's the single solution. And below that we also have the overstress solution, and this is a solution that uses members that are slightly overstressed, slightly beyond the capacity. So we could use that as a starting point in our optimization. Another thing of note is that we can now see the bolts, the number of bolts required and their size, and we can also see a red line here indicating the capacity of the purlins. And if the bending moment diagram fits within the red line, then the structure is satisfactory. If I click on these other buttons over here, I can look at the action capacity diagrams for the one solution. I can also look at the results for the overstress solution. And you can see here under the overstress solution, there's an action capacity table here. And we can see that there's a little red bar, and this indicates that the structure is slightly beyond capacity. If I hover over that red bar, a little box will pop up. It gives me the maximum action on capacity ratio, which is 102% in this case. It tells me where it occurs, which load case. So load case 2, it's in span 1 and it's in the second segment, and that segment is between bridging row 1 and the point of contraflexure in that span, and the mode of failure is due to bending moment and compression. So that gives us a bit of information that we can use to help improve our design. So red indicates that the structure is not okay, whereas green tells us it's a pass, it's satisfactory. So the next step would be to look at optimizing this design to try and use less material. So we can see down here we have a starting point for our single solution. It's telling us that we have 181 kilos of purlins and 6 rows of bridging, and that is for each purlin run. And it's also important to note that the mass does not include the bridging. So you have to make sure that when you're looking at the total roof, you multiply the purlin mass by the total number of purlin runs. So to start the optimization, what we'll do is we looked at our overstress solution, and we will copy that to our override case. And when we click on that button, a little box will pop up that tells us we can now edit lap and bridging positions by clicking on the lap or bridging. We can move to an exact location by clicking on lap and bridging and then right-clicking, or we can delete bridging by right-clicking and selecting delete, or we can add a row of bridging by clicking on the Add New Bridging button. We click on OK, and what we can now do is try and improve this design. So the first thing that I might do is move the bridging in span 1 closer towards the middle. So at the moment it's at 0.42. I can just left click on it and drag it to 0.5 and drop it. So it's now at 50%, and let's just click on recalculate and see whether that improves things. Okay, so immediately I can see that I've made things worse. The action on capacity ratio in the first segment has now gone up to 124%, so we've got a worse result. So I'll just keep that solution, so click on yes. And you can see that that now stores it in the program, so I can refer back to that later. I'm going to copy the overstress solution again, and this time I'm going to increase the lap. So at the moment we're at 7.5% lap on span 1. What I'm going to do is move that. I can either left click on it and drag it, so I can drag it out to some number and let it go, or I can also right click on it and go lap new value and actually type in a number. So I'll set it as 15% and click on OK. You should be able to see the number update there on the screen, and we'll click on recalculate. Okay, so again the results show we've got a very marginal improvement, now 101% over capacity. So slightly better, but not enough. So again I'll say yes to keep that, and again it gets added to the set of results. And the next step I might try, I'll copy the overstress solution. This time we might add a new row of bridging. So I'll click on the Add New Bridging button. When you do that, you'll see a little X inside a box drop in here. This is our row of bridging. I can now left click on this and pull it across and drop it onto span 1. And I'll select yes to locate it at the default position. So now we've got 2 rows of bridging in span 1, and I'm happy with that. I'll click on recalculate. So now we've got green all the way across the roof. So that's a design that passes. So I'll click on yes. And so now under override case 3, we can see that we've got a structure that is 173 kilograms with 7 rows of bridging. So we've made a marginal weight saving. Now you can continue working on this, playing with the different parameters, and engineers typically can get around about 20% savings on purlins based on the starting solution. Okay, so now what I want to do is I want to go back and show you how the check purlin size works. So I'm just going to click on return to editing spans, and I'm going to click on check purlin size. And engineers can use this when they have a reasonable idea on what purlins they believe they need. So once I've clicked on that, the purlin size boxes here will now become active, and I can select from a drop-down what size purlin I wish to use. So I'm going to use 212s. So I just go through and select them. And also I just want to show you, if I select the wrong size purlin, if I try and put, say, a 300 size purlin with a 200, I'll get an error that the purlins need to be the same depth. So again, the software has error trapping that will try and pick up the major mistakes that a user might make. So I'll change that back to a 212, and I'm going to leave everything else exactly the same and continue on. Again, I'll get the same warning that I did last time. The load cases are all set up from earlier, and if I click on calculate, it now gives me the bending moment diagrams and shear force diagrams like I did earlier, and I can proceed on to moment capacity design. And this time it gives me the calculation, and it shows me that my structure is overstressed in span 1 for load case ZZ. At this point there's nothing I can do now. There's no ability to change the design. This is just a check. So if we want to make a change, we'd have to go back to the first page and make changes on our load and span input pages. The next thing I wanted to show is the X-facta files themselves. They are saved in an ASCII format. They're called PMC files, and if you look through them you can see that the format's quite easy to understand. You can see the spans, numbers of rows of bridging locations and lap lengths, etc. As you move through the file, if you've saved results, you can also see the results saved in here. Things like purlin sizes, etc. are all saved in the model file. So that's a X-facta model. Also, if you look in the location where the X-facta software is installed, so under Program Files, under Stramit Building Products, X-facta, if I go to Support and under Examples, there are 2 models in the Examples directory, Test Project 1 and Test Project 1 After Analysis. One just contains the model setup, whereas the other one contains the results. So I'm now going to open up one of these models in X-facta, and we'll have a look at that a bit further. Okay, so the last thing that I want to demonstrate now is the show design results, and this is useful for printing off reports of the design. When we click on that button, we'll see show calculations for, and a number of different options here depending on what you've calculated. So first of all, we can see input information, and this gives us the model, the setup, the spans, the lap lengths, etc. We can see a summary of the results. We can also see various sizes that were selected for different load cases. We can get the single solution, the overstress solution, and we can also get results for override cases, etc. So I just want to show the results for the overstress solution on this example model, and let's have a look at, say, serviceability and strength on wing case. I click on OK, and the software will now generate reports. First thing to note here is that this looks a little bit blurry. Now this isn't a software fault, this is an issue with Windows clear type text. So let's fix this. So to show you how to do that, I can just minimize the software, go back to the desktop, right click, click on personalize, click on display, click on adjust clear type text, and you'll see at the moment that clear type's turned on. If I turn it off, click on next, and then click on next, 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 and next, finish, and then I can close that. Now if I go back to my report again, show design results for overstressed, okay, and you can see now that the text is much clearer to read and it's no longer blurry. The other point of note here is that if it's blurry on the screen, it will also print out blurry as well. So it's important that you rectify this issue if you're having this problem. So it shows here now the overstressed solutions for CLC1, or if I want to look at CLC3, I just click on it. It generates that report as well. And I can scroll down and see the design. I can see the purlin sizes that were selected, bending moment, shear force diagrams. I can see information about the structure, and all of this can be incorporated into your design report. To print this off, I can either click on the Print CLC3 button here at the bottom for the single load case, or if I want to print off all the load cases that I've selected, I can click on the Print All button. The software can also print off each of the pages, so if you wish to refer to a design like how it was set up in Exacta, you can go to File, Print, and for this I'll go File, Print, Preview. Usually you want to do landscape, and you can see here it will print the page exactly as it appears on screen. Finally, if you need any help with the Exacta software, before you call up or before you send an email, go to the Help menu and click on About Exacta, and this will give you the version number. And it's very important that you let us know what version of the software you're running in case a newer release is available. This concludes our video training series on Exacta. If you missed our earlier videos, I invite you to go back and watch part 1, providing you an overview of the software, or part 2 on the installation and registration process. I hope you found these videos useful and that you are able to put the Exacta software to good use.